Hi guys, today we'll be talking about special triangles and their trigonometric ratios. Okay, so there'll be three separate angles that we'll be discussing. The first is 45 degrees, the second is 60 degrees, and the third is 30 degrees. Now, you might have heard of the three angles separately, but first I'd like to tell you about why they are significant and how these three angles are related. So let's start with 45 degrees. To show you how it is significant, I'm going to draw a square. Okay, so in the square, I'm going to divide the square into two. So as you are aware, these sides are all the same. Okay, so the ratio of this side, of the bottom to the side, is 1 to 1 because it's all the sides in a square in the quadrilateral are the same length. And obviously in a square, this is a right angle. So now since the ratio of these two sides are 1 to 1, we can treat this as the hypotenuse of these two sides. So 1 square, so to find the side x here, x square is equal to 1 square plus 1 square. X square is equal to 2, x equals the square root of 2. So x becomes the square root of 2. So given a square where both sides, all the sides are equal, we can get the ratio 1 to 1 to the square root of 2. So now since this is a right angle and the total number of the total angle in a triangle is always 180 degrees. So 180 degrees minus 90 degrees divide by 2 gives us 45 degrees. So since this triangle has to total up to 180 degrees, this is 90, so this becomes 45 and this becomes 45. So this introduces us to the first triangle in trigonometry, the 45 degrees triangle. Now, introducing the trigonometric ratios of the 45 degrees. So since this 1, 1 and square root of 2, this is also 1 and 1. But for now, let's treat this as a single triangle. Let's remove the other half of the square. Okay, so now we have this triangle, the 45 degree triangle. Now we know how it was found in the first place, so now let's calculate the ratios. So sine of 45. So we can use either for either angle. We can either use this one or this one. So let's consider this one as the base 45 degree angle. Okay, so sine is the opposite over the hypotenuse. So the opposite to this is 1, and the hypotenuse of the entire triangle is the square root of 2. Is also, once we rationalize, is also known as the square root of 2 over 2. Now the cos 45. Cos is the adjacent over the hypotenuse. The adjacent of 45 degrees is also 1. As we can see here, it's on the same line. So 1 hypotenuse is the square root of 2. Is also the square root of 2 over 2. Now the tan of 45, this is a very special angle in trigonometry. The tan of 45 is opposite over the adjacent, so the opposite is 1. The adjacent is also 1, so 1 over 1 gives 1. So this introduces the very first special angle in trigonometry, the 45 degrees. And this triangle is made by cutting a square in half. Because all the measurements are the same, the ratios are maintained, and it gives us two 45 degree triangles. Okay, these are two very special angles because these two are actually related. Let me tell you how. Okay, let's have an equilateral triangle. Okay, all three sides are the same, are exactly of the same length. Okay, these are all the same length. Okay, now let's divide this equilateral triangle into two different triangles. Okay, so now we have two right angle triangles. Okay, and the sides are still the same. So in this right angle triangle, since this is 90 degrees, this becomes 60 degrees. Okay, and since it's 60 degrees, by the law of triangles, both sides will have the same angle. You see, all sides in an equilateral triangle are the same length, and therefore all sides have the same angle. Okay, and 180 degrees divided by 3 is 60 degrees. So all three sides are 60 degrees. And since this angle is 60 degrees, since it's 60 degrees and it's divided into half, this is 30 degrees and this is another 30 degrees. So now we've already found these two. We have found 60 and 30. Both angles are here. And this is 90 degrees. So overall, these two make two separate triangles. And overall, 60 per 60 per 60 makes a giant triangle on a macroscopic scale. So now let's analyze the ratios between these triangles. Okay, so since this is divided into two, okay, this line is divided into two, let's treat this as 1 and 1. Okay, this becomes the square root of 3, and this becomes 2, and it also becomes 2. So now based on this triangle, now let's do this the 60 degrees here, and let's do 30 degrees here. So 60 degrees, we can either use this or this. So the measurements are the same, the ratios are the same, the signs are obviously the same. So the sine of 60 degrees, considering the base angle is here of 60 degrees here. 60 degrees, the opposite is the square root of 3. Okay, the square root of 3. And the hypotenuse of this triangle, the one we're dealing with, is 2. So becomes the square root of 3 over 2. Cos of 60 degrees, the adjacent of the 60 degrees here is 1. Okay, and the hypotenuse is 2 of this triangle. Tan of 60 degrees, opposite is square root of 3, adjacent is 1, makes tan 60 degrees the square root of 3. Now for 30 degrees, the sine of 30, okay, so let's take this angle. The sine of 30 degrees, opposite over the hypotenuse, here opposite over the hypotenuse. Cos of 30 degrees, the adjacent of 30 degrees is square root of 3, or hypotenuse of this triangle is 2. The tan of 30 degrees is the opposite, which is 1 over the adjacent, which is the square root of 3. So 1 over square root of 3, this can also be written as square root of 3 over 3 when it's rationalized. Okay, so these are the 3 special angles in trigonometry. Yeah, soon we'll learn why this is very significant. Okay, thank you very much. The blueprint is out. Okay, the blueprint will summarize everything that's been said in this video and the neat version of all the 3 triangles. Okay, so see you in the next one. Thank you.